In the mapping view, we can investigate the different types of mapping techniques. For example, the HugMe technique for semi-automatic mapping. It uses a set of already mapped nodes and the set of nodes that it should map automatically, the orphan nodes. In this view, we can investigate the dependencies between the map nodes and the orphan nodes, and the internal dependencies between the orphan nodes themselves. We have also implemented another technique based on naive Bayes classification. In this view, we can investigate the bag of words generated from the source code of the map nodes. We can try these mappings and investigate and compare the results. We can see that all orphan nodes are mapped correctly by both HugMe and naive Bayes. We can also note that the file update monitor was mapped by the naive Bayes mapping, but not by the HugMe technique. This is because of the rather high omega threshold. In the experiment view, we can define interesting experiments using different types of mapping techniques, bundled systems, and parameter ranges. For example, maybe we are interested in the effect of using the word count parameter in our naive Bayes mapping technique. So let's add an experiment. We will use two systems. For one experiment, we will use the word counts. We will not use any stemming for this experiment. We will give it a name. We will use random metrics, and we will set a nice color. We would of course like to have a corresponding experiment that does not use the word counts. When we are done with our experiment definitions, we can run them. And when we have some data, it will show up in these three scatter plots. Alright, we are back. Using power selection, we can, for example, take a look at one system at a time. This node is a Leucine node, and by clicking it, we can now filter out all the Leucine-based experiments. And we can see that for JabRef at least, it seems like the red nodes are definitely have better performance and better precision. So maybe this experiment is interesting enough to run at a larger scale. And we can do so by saving our experiment in an XML file and then run it in our external tool that runs on a multi-core server. The EXR Owner tool is our command line based tool for running experiments in parallel. Typically this is executed on a virtual machine that has many cores available. You can define which experiment to use. We use our saved experiment XML file. You can define how many experiment iterations we would like to run, in this case 50,000, and how many threads we would like to run the experiments in. In this case, we have 2 experiments and we would like 8 threads per experiment. We have a 16-core machine in this example, so it makes sense to have 1 thread per core. We can use the top command to inspect the utilization of the CPUs that we have. We can also inspect the output directory, and we can see that we have 2 directories, one for each experiment that was created. And we can see that we have created a number of CSV output files, one for each thread in this case. We can use these CSV files, download them, and use them in, for example, a statistical analysis program for continued examination of the experiment data. Thank you for watching, and I hope you found our tool interesting.